Welcome viewers. So in this video lecture, we want to talk about generating generating functions. So what is a generating function? This we want to learn. Okay. Now consider a sequence. Consider a sequence an. Okay. Then the generating function is denoted by GAZ, and it is given by GAZ equal to summation n vary from 0 to infinity an into z raised to the power n. Okay, so this is how we write the generating function. Now notice here one thing, that if here you have an, so here you are using a. Okay, and if here the variable is z raised to the power n, then you are using here z. Okay, so sometime in other books you may be given a notation like this gyt. In that case it means that here we have summation n vary from 0 to infinity. As this is y, so it means that the sequence is yn, and the variable here is t raised to the power n. Okay, so you people remember these notations, but in our video lecture I will be using this notation only. Okay, so this is the compact form of the generating function. Now if you want to find the expanded form, so what you do, one by one you substitute the values of n here. So when the n value is 0, so it is a0 z raised to the power 0, a1 z raised to the power 1, a2 z raised to the power 2, a3 z raised to the power 3, and so on. So anything raised to the power 0 is 1, so it is only a0 plus a1z plus a2z square plus a3z cube, and so on up to infinity. So in the expanded form, this generating function, it is expressed like this. Okay. So what I want is this, that you people remember this expression, that generating function, it is expressed like this. Okay. So you remember it. Now from this expression, we can obtain one more expression by bringing this term to the left hand side. Okay, so this is gaz minus a naught. Okay, this is equal to a1z plus a2z square, a2z square plus a3z cube, and so on up to infinity. So this you also remember. Okay, uh, you can obtain this expression directly from this, but if you remember it, okay, then while solving question it will be very easy for you to solve the question. Okay, so this is the second expression which I want you people to remember. Okay, now one more expression I want you to remember. Now bring this term to the left hand side again. Okay, so what do you get? You get here gaz minus a naught minus a1z. This is equal to a2z square, a3z raised to the power 3, and so on up to infinity. Okay, so this is the third expression which I want you people to remember. Okay, so you remember this also. So all these three expressions, they are very useful expressions and they will be used for solving the questions. Okay. So now we see that in the next part that if you are given one sequence, then how to obtain the generating function from that sequence. Okay. But before that, you notice here one thing that we used this thing that 1 minus x raised to the power minus 1. Okay. The binomial expansion of this is 1 plus x square plus x cube plus x raised to the power 4 and up to so on infinity. Okay. So this will be used in the questions. Okay. So the question is this, that if we have this sequence an equal to 1 where n is a whole number, okay, a whole number starts from 0, okay, then find the generating function. Okay, then find the generating function. So it is very easy. See, we know that what is the definition of generating function. It is gaz summation n equal to 0 to infinity an into z raised to the power n. So you set n value equal to 0, so it is a0 z raised to the power 0, that is 1, so we need not to write that. A1 z raised to the power 1, a2 z raised to the power 2, a3 z raised to the power 3, okay, up to so on infinity. But you people notice here that this sequence, okay, it is a constant sequence. Every time this takes value 1, okay, so it means that its first term a naught, it is 1, okay, a1 is also 1, so 1 into z is what, it is z, a2 is also 1, so this is what, this is z square and plus so on. Okay, now you compare this thing, okay, you compare this thing, this thing, this thing with this expression, okay, with this expression, okay, you compare it with this expression, okay. So once you compare it, so from this we conclude that this can be written as 1 minus z raised to the power minus 1, okay. So 1 minus z raised to the power minus 1 is what, it is 1 by 1 minus z. Okay, so if your sequence is 1, in that case your generating function is 1 by 1 minus z. But somebody can ask this question in the reverse direction also, that if your generating function is this, then what is the sequence? Okay, then you promptly answer that in the sequence it should be 1. Okay, so if your generating function is 1 by 1 minus z, then the sequence is what, sequence is in that case 1. Okay, now see the next question. So the next question is this, if we have suppose the constant sequence like this, an equal to c, where n belongs to w, find the generating function. Okay, find the generating function. So solution, gaz, this is equal to summation n equal to 0 to infinity an into z raised to the power n. Okay, so in expanded form this can be written as a naught plus a1 z plus a2 z square a3 z cube and so on up to infinity. Okay, now what is the a naught value? A naught value here is c. Okay, a naught value is c. What is a1 value? It is also c. A2 value, it is also c. Okay, likewise. Okay, now what we do, we take c common from here, so it is 1 plus z square up to so on infinity. So what is the formula of this? So this is 1 minus z raised to the power minus 1. Okay, so this can be written as c upon 1 minus z. Okay, so if your sequence is like this, okay, I mean if you are given any constant here, then the generating function of this is c by, I mean constant by 1 minus z. For example, if somebody gives you this sequence, an equal to 2, where n belongs to w, then you promptly say that generating function of this, it is of the form constant by 1 minus z. Okay, and if somebody gives you this generating function and they ask that what is the sequence, then you tell them then that this number, okay, it is the sequence for this generating function. Okay, now we solve the next problem. See, the next problem is this. Next problem is this, that suppose that we have sequence of the form alpha raised to the power n, okay, where n belongs to whole number. Find generating function. Okay, so this sequence, it is not a constant sequence. Okay, as you change the value of n, so the each term, okay, it is different then. Okay, because alpha naught, it is 1, and alpha 1 it is alpha, and a1 it is alpha square, like this. Okay, now what is the generating function for this? Gaz. Gaz, it is equal to summation n equal to 0 to infinity an into z raised to the power n. Okay, so this can be written as a naught plus a1 z plus a2 z square plus a3 z cube and so on. Okay, but what is the value of a naught? You set n value equal to 0 here, so it then becomes alpha raised to the power 0. Okay, what is the a1 value? It is alpha raised to the power 1, z raised to the power 1. What is a2 value? It is alpha raised to the power 2, z raised to the power 2, alpha raised to the power 3, z raised to the power 3, and so on. So anything raised to the power 0 is what? It is 1. Okay, plus alpha into z plus alpha into z whole square plus alpha into z whole cube and so on. Okay, you see that what is the binomial expansion of this? It is 1 minus alpha z raised to the power minus 1. So it is 1 by 1 minus alpha z. So this number, it is a very useful number. Okay, if it is alpha raised to the power n, then your generating function, it is of the form 1 by 1 minus alpha into z. Okay, so you see that if somebody gives you this sequence, an equal to 2 raised to the power n, so for this we can say that the generating function, it is of the form 1 by 1 minus 2z. If somebody gives you this type of sequence, okay, then you say that generating function, it is equal to 1 by 1 plus 5 into z. If somebody gives you this sequence, okay, like 7 raised to the power n, then generating function for this is 1 by 1 minus 7z. Okay, so you can switch between these two. If you are given this generating function, then you can tell that this is the sequence, and if you are given this sequence, you can tell them then this is the generating function. Okay, so this is very important. Okay, while solving questions, it will be used. For your practice, I give you one question. Okay, so for example, GAZ, if you have suppose like this 1 by 1 minus 3z, and somebody asks you that what is the corresponding sequence for this. So the sequence, it is 3 raised to the power n. Okay, in this number raised to the power n, where n belongs to w. So this is the answer of the problem. Okay, So we want to solve one more question of generating function. So suppose that the sequence is this sequence 1 by n factorial. Okay, here n belongs to w. Find the generating function. Okay, so solution gaz, this is equal to summation n vary from 0 to infinity an into z raised to the power n. So it is what? It is a naught a1 into z, a2 into z square, and so on. Okay. Now you see that what is the value of a naught? Value of a naught is 1 by 0 factorial. What is value of a1? It is 1 by 1 factorial into z. What is value of a2? It is 1 by 2 factorial into z square, and so on. Okay. 1 by 0 factorial, this is equal to 1, and this is z by 1 factorial. This is z square by 2 factorial. In this way it continues like this. Okay, but this thing, okay, you see that this is the expansion of e raised to the power z. Why? Because e raised to the power z, it is equal to 1 plus z by factorial 1 plus z square by factorial 2 plus z cube by factorial 3. Okay, so this is the expansion of e raised to the power z. So it is very important. Okay. Now, after this, we solve one more question. Now we start solving the questions. So, in order to make you people understand, I just take very simple example. So, solve the following recurrence relation an minus 1 equal to 0 with a0 equal to 1 using generating function. Okay. So, solution. Your given equation is this an minus 1 equal to 0. Okay, see here we want to use the generating function technique. So generating function, it is given in this form and vary from 0 to infinity an into z raised to the power n. So with the an, what do you require? You require z raised to the power n. So what you do? You multiply this equation with z raised to the power n. So an into z raised to the power n, an minus 1 into z raised to the power n. Okay. Now next thing is this, that take this summation. Okay. But the question is this, that from where should we run this summation? Okay. See, we should start this summation from that number. Okay. uh, which does not make these subscripts minus. Okay. These subscript, they should not be negative subscripts. Okay. So from that number you started. So suppose if I started from 0. Okay. So in this case here it 0 minus 1, it is minus 1. So these subscripts then become negative. So we cannot start it from 0. Okay. We allow value uh, positive values to come, or 0 can also come. Okay. So if we start this summation, okay, this summation from 1 to infinity, in that case it becomes 0 and it becomes 1. So in that case no subscript, it remains negative. So take the summation which runs from 1 to infinity an into z raised to the power n, summation n vary from 1 to infinity an minus 1 into z raised to the power n equal to 0. Okay, you notice this thing, that what is the condition? Condition here is a not equal to 1. Now after this what we do? We substitute the values of n here. Okay, so if you substitute a value of n here, so it becomes a1 into z raised to the power 1 a2 z raised to the power 2 and so on. Okay, and what is it? Set n value equal to 1. So it is a naught z raised to the power 1. Set n value equal to 2. So 2 minus 1 is what? It is a1 z raised to the power 2 and so on. Okay, it is equal to 0. Now you see here this equation is completely balanced equation, because with a1 we want z raised to the power 1, with a2 we want z raised to the power 2. So it is a2 z is z raised to the power, sorry, it is a1 z raised to the power 1, a2 z square and so on. But this part it is not balanced, okay, because with a1 we only want z, we do not want z here. So in order to make here balance, you take z common, so it is a naught plus a1 z and so on up to infinity. Okay, now you were told this thing, that what is the formula of this in terms of gaz. So it is gaz minus a naught, and minus z, what is it? It is g a z only. Okay, this is generating function. Now after this you uh, apply this condition that a naught value it is equal to 1, so it is gaz minus 1 minus z into gaz into gaz equal to 0. Okay, now what we do after this, we combine the terms containing gaz. So this term contains gaz, what is its coefficient? Its coefficient is 1. And this term contains gaz, so minus z into gaz, and take this minus sign or on the other side, so it then becomes plus 1. So this is gaz equal to 1 by 1 minus z. Okay, so this is the generating function. Okay, so if you are asked that give only the generating function, then our question finish here. But if you are asked that what is the sequence for this, because you were given the recurrence relation, and in case of recurrence relation uh, the solution is always written as an equal to. Okay, so here the sequence for this is 1. Okay, you were told that whenever this is the generating function, then the corresponding sequence for this is 1. Okay, so this is the answer of the problem. Okay, this is the answer of the problem. So more about it will be discussed in the next video lecture. Thank you very much viewers for watching this video. In the next video lecture we will discuss some more questions of recurrence relation.